Hey, what's going on, everyone? This is going to be the intro to GitHub stream. Just got started, so we'll wait a couple minutes, see if get some people in. So with that, see you guys in just a few. Okay. Let's get this show on the road. What's going on, everyone? I'm Zane. I'm a coach here at MLH, and today I'm going to be taking you guys through intro to GitHub. So should be pretty exciting stuff. Hello, hello. What's going on, everyone? Loving the smiley faces too. Fun, fun, fun. Let's see. Let's get this show going. So intro to GitHub. So we're going to talk quite a bit about GitHub, how it works, what you guys can expect from it. And really, I think the best thing to do is just to dive in. So, here we go. More and more people love it. Have any of you ever used GitHub before? Is anyone familiar with GitHub? Very, very powerful tool, especially when paired with Git for code collaboration. And well, you'll come to see what it's all about as we talk about it today. Okay, so GitHub users, love it. Use it for Hacktoberfest, nice. Oh yes, there is the check-in for the event. Very, very good point. Here, let me get rid of this banner too. Here we go. Let's go to GitHub events. Let's see. Let me go to my super top secret source for all the events. We have go to GitHub. That's probably beat me to it already. Oh no, there we go. Okay. Here you all go. You can just sign up for the event. And it'll just give you some perks, lets us know who's all interested, gives us some metrics, all that good stuff. Okay, so seems like we've got quite a number of people in here, and got the link in there to check in. So let's just get started. Let's talk about what GitHub is at first. So GitHub is a web-based platform and a service for version control and collaborative software development. It provides a place for developers and teams to host, manage, and track changes to their code, enabling efficient collaboration and project management. So some of the things that you want to be aware of when it comes to GitHub, just some of the features, and I guess just an overview of the platform overall. One of the big things is version control, which we'll be talking about in detail a little bit later on. But GitHub is primarily used for version control, which is the practice of tracking and managing changes to software code over time. It allows developers to work on projects without interfering with each other's work. It provides a history of changes, making it easier to understand and fix issues. This is super nice. So imagine that you're working on an application or a website, something of the sort, and you have a team that's working on like the user interface and the visual design, and you have a team that's working on the maybe like the back end and the stuff with the servers. Or just as a simple example, you can break up the project to where the UI visual people have their own copy of it that they can like make changes to, and it won't affect the copy of the backend developers, what they're doing. So it's super nice because people can make their own, they can make changes without breaking things potentially for anyone else or without changing things needlessly for anyone else. We'll definitely see that in detail as we continue through this. But that's version control. Another feature are repositories. So basically in GitHub, code is organized into what we call repositories. A repository is a collection of files and directories, along with the version control history of those files. It can be public, allowing anyone to view and contribute to the code, or private, which restricts access to a select group of collaborators. Another feature is collaboration, so that more people can get notified and join. Ooh, very, very good point. In fact, let me post that now. So yes, we want everyone to get in on the fun. Let me post this real quick, and then we'll get right back to the action. Let's see. Okay. So in the Discord, I'm saying we're doing intro to GitHub. I'm join the fun. Okay. Oops. I meant Global Hack Week. There we go. Okay. I accidentally did I add everyone. I'm like an old man when it comes to things like Discord. I don't know why. It just rattles my brain. Anywho. So the program had not started. No, here we are. We're doing the GitHub. I just took a little hiatus, a quick short second to do to post in the Discord after Skiddy made a good point on that. So with that, let's jump back in. So we have version control that we've covered. We have repositories. We have collaboration. So GitHub facilitates collaboration by allowing multiple developers to work on the same project, kind of as I was talking about a little bit before. Developers can clone a repository to their local machines, make changes, and then push those changes back to the GitHub repository. This makes it easy to work on software development projects as a team. There's also branching and merging. So GitHub supports branching, which allows developers to work on separate features or bug fixes without affecting the main code base. So again, a little bit of what I was talking about before. Branches can be created, modified, and merged back into the main code base using pull requests, which enable code review and discussion before integration. There's also issue tracking. GitHub includes an issue tracking system, making it easy to manage and prioritize tasks, bug reports, and feature requests. Issues can be assigned to team members, labeled for categorization, and linked to specific code changes. There's also social coding and community. GitHub is more than just a version control platform overall. It is a social network for developers. Developers and teams can follow each other, store and fork repositories, and engage in discussions related to code changes and issues. This fosters a sense of community and knowledge sharing among developers. And these sorts of additional features that we're hearing about and talking about, like forking repositories and version control, so on and so forth. We're going to go in a little bit more detail in just a few. So another feature or aspect about GitHub to know is with integration and automation. GitHub supports integration with various third-party tools and services through its extensive API. This allows for automated workflows, continuous integration, and deployment pipelines, making it a central hub for the software development lifecycle. And last but not least, and very, very topical for this Global Hack Week, is open source, as well as private projects. GitHub is widely used for open source projects, but also supports private repositories, making it a versatile choice for both public and proprietary software development. So overall, GitHub has become an integral part of modern software development. not only for individual developers, but also for teams and organizations working on open source and private projects. It provides a robust set of tools and features to streamline the development process and enhance collaboration, making it an essential platform for the software development community. So especially, again, I think everyone here at MLH and people interested in MLH are most likely familiar with GitHub and just the value that it provides to developers as a whole. If you are not aware of that just yet, you will certainly come across Git and GitHub in your software development journey, and really just realize the unfathomable utility of such a tool. And we're going to discuss that all the more coming up. So let's just talk a little bit about version control, which is really just the basis of GitHub, I would say. So version control, also known as source control or revision control, is a system that tracks changes to files and directories over time. It is a crucial tool used in software development, content creation, and various other fields where managing and collaborating on digital files is essential. So in terms of just sort of giving an overview of the key features and benefits of version control and version control systems. The first would be history tracking. So version control systems maintain a detailed history of changes made to files. Each change is associated with metadata, including the author, timestamp, and a description of the modification. This historical record provides a clear timeline of project development. Let's see. Sugatskidi. Okay, nice. Yeah, I would imagine that for some of our past events where that are a little bit more hands-on, where people can contribute their own code and just learn how to make their own coding projects. You most definitely use GitHub. And two, if any of you have looked into MLH's other just offerings and the like, there's also like the MLH Prep program or the MLH Fellowship. You are absolutely going to be using GitHub for those. Here we go. You're absolutely going to be using GitHub for those to be able to collaborate on code effectively with your pod mates and such. So, anywho, so there's history tracking, maintaining a detailed history of changes made to files. Another feature or aspect of version control would be the collaboration aspect. So, as we were just talking about, version control systems enable multiple developers to work on the same project concurrently. It prevents conflicts by allowing each user to create their own branch of the code, make changes independently, and merge their work with the main code base when ready. So this is actually one of my favorite things to explain to non-programmers, people that are relatively new to the field of software development or that just don't know anything about it. Explaining a tool like a version control system, they really come to appreciate just what that means for collaborative development, where you can have that main source, you can copy it, branch it off, different teams can work on different aspects of the project, improving it without messing with anyone else's, or two, without messing with the main source, giving you control of what you want to ultimately be added and reflected in that main source. So super invaluable, very helpful. Okay, so next, another feature of version control it's good to know about is branching and merging. So it goes a little bit deeper into this idea of being able to work on something concurrently without needless conflicts. So version control systems allow developers to create branches, which are separate lines of development. Branches are typically used for different features, bug fixes, or experimental work. After development is complete, these branches can be merged back into the main code base. So sort of like we were talking about earlier too, like say you have your main project and you want to add or change things about the user interface, and maybe the backend team wants to change things about the I don't know, something with the serving or data collection. They can each copy the main starting point of the code base, do their own things. They can even branch off from their initial branch off. They can branch off from their initial branch off to try new features on their initial branches, and from there it just gives you the freedom and control to to, as it said, experiment, try out different features, attempt bug fixes, so on and so forth. So next up, we have conflict resolution. So when multiple developers make changes to the same code simultaneously, conflicts may arise. Version control systems provide tools to resolve conflicts, ensuring that changes from different sources can be combined harmoniously. Backup and recovery. Version control acts as a backup system. If a mistake is made or code is accidentally deleted, previous versions can be restored. This is particularly valuable in avoiding data loss. Here we go. What's going on, Shoyo? Thanks for hopping in, everyone. We appreciate the support. So with that, we had backup and recovery. Next is documentation. Developers can provide descriptive commit messages explaining the purpose of changes. This documentation helps team members understand the history and context of code modifications. So the way that I usually describe it to people, especially to non-developers that are just kind of interested in how all this stuff works, is that when you're working on the code and you feel like you reach up to a meaningful point, you can take a snapshot of the code as you currently have it. And with that snapshot, you can do this continually. So say you work on the code a little bit, it's at a good point, you take a snapshot, work on the code a little bit more, take a snapshot, work on the code a little bit more, take a snapshot. Once you're at meaningful points where it feels like a good place to I guess you could say, like, save your progress. So the nice thing is that you can jump between these different snapshots of your project if need be. Say you go super far ahead in development and there's something that you just don't want to keep, you can work your way backwards. Or two, the nice thing about these snapshots is, again, you can, as it says here, you can basically add additional information to these snapshots, to these different commits and such. And the nice thing about having context is that, say you come back to a project like 6 months later when you forget everything, or you're working on someone else's project and you're just trying to dive in, understanding why certain things of code were implemented, why certain changes were made, so on and so forth. This additional context just gives you all of the reasoning behind things, as long as that documentation is well put together. With that, it's it just gets you up to speed and it's pretty valuable. Saves you a lot of time, headache, and can provide context that you might not even be able to easily figure out yourself, if ever. See, is there a way to put a whole project on GitHub if I coded the whole thing on my local machine? I'm having trouble doing that because the commit only allows you to put a little amount of change in a repository. There's an obvious way to upload a full project on GitHub. Yes. Well, I guess it depends too on what you mean by a whole project. There's definitely, as far as I understand, you can certainly put up anything that you can conceive of on GitHub. And it doesn't have to be just like one file or a set of files. You can put entire projects if you just make a repository, sync that repository up with a with the folder that houses everything that you're aiming to sync with GitHub. Then that should be possible. So we're going to go over, so we can put anything in a GitHub repo just about. So we're going to go over some stuff like that too in time. So don't worry about that. Yeah, if you're having trouble with it though, it's definitely worth doing some additional Googling and maybe even jumping into the MLH Discord or similar communities. There's also this GitHub communities. In fact, let me skip a little bit ahead. Boop, 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 boop. Look at that. Look at all this great stuff I'm going to jump into. So there's different resources that you can use to help yourself get a handle on GitHub and just get some insight on any issues that you may be having, any questions that you may have. These are some of the learning resources that you can jump into. For anyone that has any questions on just using GitHub, what's possible with it, if there's an issue that you're looking to overcome, these are certainly good resources. So, like take a screen cap or something. We are eventually going to work our way up to this, but I figured now would be a good point to just at least make it known that there are these different resources and communities that will help give insight on such things. So with that, we're still a ways away from that. Let's get to here. Oh yeah, absolutely. Happy to help. So we were talking about version control. So with that, documentation, right? It's not just enough to make your snapshots, to make your Git commits and such. You also want to give context to them so that when you go back to a project or when someone else goes to your project, they understand how you built it. They understand the context behind every change. So another feature of version control to be aware of is, or version control systems, is code review. So version control systems often include features for code review, allowing developers to comment on and discuss proposed changes before they are integrated into the main code base. There's also the aspect of security and access control. Version control systems offer access control mechanisms. Repository owners can control who can view, modify, or merge code, ensuring data security and compliance with organizational policies. So especially helpful for just abiding by anything to do with security. And if your own company has its own, internal ways of doing things, its own internal policies, then you can also mock up the system to automatically check for such things. Super, super helpful. And then last but not least on this list, just another feature to be cognizant of in our overview of version control is traceability. So version control enables traceability of changes, which can be essential for auditing, compliance, and project management. And there are various version control systems available. Git is sort of the one to know about, especially. So Git in particular has become the most popular version control system due to its speed, flexibility, and strong support for distributed development. Version control overall is a fundamental tool in modern software development, helping teams manage complex projects, collaborate efficiently, and maintain the integrity of their code base. So we're going to go into some detail on Git a little bit later. A lot of things we're going to do a little bit later, but that is going to be one of them, going over Git. But ultimately, the focus is on GitHub, so I do want to give some additional context and appreciation. Okay, but my computer almost blue screened. That was weird. This is weird. Hold on. Let me make things sure. Here we go. Okay, thought things were breaking for a second. Anywho, what were we saying? Ooh. Hold on. I do not like this. Here we go. Okay, I don't know why things are misbehaving, but here we go. Okay, so with that, let's talk about GitHub history and significance just a little bit, just to lay the groundwork, lay the foundation for just, how it became what it is today. So the history and significance of GitHub are closely intertwined, as its growth and evolution have played a significant role in shaping modern software development and collaboration. So let's talk a little bit about the history. It was founded in 2008, and it was created as a response to the need for a better platform for version control and collaboration in software development. At the time, there were other version control systems, ones such as Subversion and Mercurial, but they lacked the social and collaborative features that GitHub would go on to introduce. In Git integration, so GitHub's founders chose to build their platform on top of Git, a distributed version control system created by Linus Torvalds. I believe that's how you say it. Git's speed, efficiency, and branching capabilities made it an ideal foundation for collaborative coding. From there was rapid growth. GitHub quickly gained popularity due to its user-friendly interface, effective code collaboration features, and open source ethos. The platform's ease of use and the network effect of having a large and active user base contributed to its rapid adoption. And two, very, very topical with our open source week here, GitHub has an open source focus. GitHub actively promoted and supported open source projects, which attracted a broad community of developers, including major technology companies and open source foundations. This ethos significantly contributed to the platform's growth. And then finally, in terms of continuous improvement, GitHub continued to evolve by introducing new features, integrations, and collaboration tools. The introduction of pull requests revolutionized code review, making it easier for teams to collaborate effectively. Pull requests will be going into detail on in this talk today. That's a bit about the history and a bit about the significance. Let's delve into the significance even more. So GitHub revolutionized collaboration. It changed the way developers collaborate on software development projects. It made it easier for multiple developers to work on the same code base, track changes, and resolve conflicts. GitHub's branching and emerging capabilities streamline the development process. Second aspect is social coding. The second aspect of significance is its social coding. So GitHub social features like following users and repositories, forking projects, and contributing to open source fostered a sense of community among developers. It made software development a more collaborative and transparent endeavor. The third aspect of significance is its open source, the fact that it's an open source powerhouse. GitHub became a central hub for open source development, as we talked on just a second ago. Many of the world's most important open source projects, including the Linux kernel, were hosted on GitHub. The platform made it easier for individuals and organizations to share and collaborate on open source software. It's also the aspect of continuous integration and deployment. GitHub's integration with various continuous integration and deployment tools and services played a pivotal role in the adoption of automated testing and deployment in software development, improving code quality and release processes. And the fun does not stop there. We also have, we have 2 little points left, or I guess about 3. Innovation and software development overall. GitHub success inspired other collaboration and code hosting platforms. It fueled innovation and development of tools, services, and best practices for software development and project management. Our second to last point of significance is with the developer portfolio professional identity. For many developers, GitHub profiles serve as professional portfolios. Employers and clients often review GitHub profiles to assess the developer's skills, contributions, and coding style. This one is very, very true. A lot of people nowadays will tell you that, like, if you ever apply for a job, put your GitHub profile down. And 2, make sure that you have some decent projects on your GitHub. Make sure that your code is of good quality, that you have good documentation on your projects, and so on and so forth. I know that for, say, like the MLH fellowship, you are often going to share a GitHub repository of a project that you did as part of your application. And with that, they're looking at, the quality of your code. They're looking at the quality of your documentation. They're looking at, do you make multiple Git commits, and do you give enough context to your comments and everything of the sort? Do you follow conventions and standards that have been put into place concerning all those things so that you can write, good quality code to the best of your abilities? Very, very, very important part of just being able to advertise yourself as a developer nowadays. So too, if you go online and look into that and try to read about it, you'll see people saying a lot of the same. So it's just an extension of your portfolio, or it just serves as your portfolio. Really depends. But yes, so lastly, this kind of goes into its history too, but definitely a big point of significance is that in 2018, Microsoft acquired GitHub, further validating its significance in the tech industry. Microsoft's commitment to maintaining GitHub's independence and continued growth has continued to enhance its role in software development. So overall, GitHub's history is most certainly marked by its rapid growth, evolution, and a strong commitment to open source. Its significance lies in revolutionizing collaboration, fostering a sense of community, and influencing the way modern software is developed, tested, and deployed. GitHub has become an essential platform for developers, teams, and organizations, and its impact on the software development industry remains profound. So, quite a bit on GitHub as a force in the world, both software-wise and kind of at large. We'll see bit more of that as well. Let's see. So I want to go over some key concepts in the world of GitHub. Some of these we've already heard about, just throughout this discussion so far. Now I'm going to give a little bit of attention to each one as right now. So first to know about is repositories. So a repository, often abbreviated as a repo, is a fundamental concept in GitHub. It's a storage space for project's files, including source code, documentation, and other assets. Repositories allow developers to organize, track, and collaborate on a specific project or code base. So repositories can be public, accessible to anyone, or private with restricted access to a defined set of collaborators. GitHub repositories serve as a centralized location for version control, collaboration, and code management. Second concept is commits. So a commit is a fundamental action in version control systems, and it represents a specific set of changes to the code. When a developer is satisfied with a set of changes or fixes, they create a commit, which is essentially a snapshot of the code at that moment, right, as we talked about before. Commits are accompanied by a commit message that describes the purpose of the changes. These messages are essential for providing context and documentation for the project's history. Commits are an integral part of tracking code changes and collaborating effectively. Third is branches. A branch in GitHub is a parallel line of development that allows developers to work on new features, bug fixes, or experiments without disrupting the main or master code base. Again, something we talked on before. Branches are essentially separate copies of the code where developers can make and test changes independently. Branches ultimately help in organizing and isolating different streams of work. Once the work on a branch is complete, developers can merge it back into the main code base. Branching and merging are core concepts in version control, and they are vital for collaborative and organized software development. So fourth, we have pull requests. A pull request is a feature in GitHub that enables developers to propose changes made in one branch and request that those changes be incorporated into another branch, typically the main branch. This request allows for code review and discussion before merging. Pull requests provide a structured way to evaluate, comment on, and approve changes. They can include discussions, code reviews, and continuous integration tests to ensure that the proposed changes do not introduce issues into the code base. Last but not least, issues. Issues are a tool for tracking tasks, bug reports, and feature requests in GitHub. They are used to manage, discuss, and prioritize work on a project. Issues can be created by anyone with access to a repository. Issues typically include a title, description, and may have labels, assignees, milestones, and comments. They serve as a central point for communication and task management within a project. Developers use issues to report bugs, propose new features, or discuss improvements. So these key concepts are the foundation of using GitHub for version control and collaborative software development. They enable effective code management, teamwork, and the organization of tasks and features, making GitHub a powerful platform for modern software development, as we have been discussing. So with all of that, what do you guys think of GitHub in terms of the overview and such? With all this set, we kind of have given the context for GitHub overall. And in just a second, we'll talk a bit about how to set up a GitHub account, sign in, how to alter your profile, so on and so forth. We love GitHub. Yes, we absolutely love GitHub. So I use GitHub just about every day in my coding. It really is an invaluable tool. So with that, I guess let's just jump into to making an account and what to know about it. Yes, perfect. Yeah, and definitely the perfect place for that with open source week that we have. And cool. Awesome. Okay, so let's delve a little bit into setting up a GitHub account. So you ultimately want to visit GitHub's website, sign up, create your account, complete the setup, verify your email, set up your profile. So we can look a little bit at GitHub's site, kind of see how that goes down. Let's see if I can share my screen. Let's hope this works. Let's see. Oh, cool. Okay, so we can see that we're here. Ultimately, to set up an account, it's going to want to be the first thing that you do, because with an account, then you can finally get started with version control. You can collaborate on open source projects, or you can work on your own code. So you can actually work on code within GitHub as well. So first thing that you're going to want to do naturally is go to GitHub's website, github.com. And you can click the sign up button in the top left corner now. There we go. So it's just your standard sign up. So, you just do blah, 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 email. Oh, wow, it's already taken. I don't know how far I want to get into this process with you guys. I mean, it's kind of a standard sign up. I think you imagine how it goes. Username 1, 2, 3. Oh, there you go. I don't want to make an actual account as of right now. I'd rather just log into mine. But you kind of get the gist. You go and sign up, make your account. And let me sign into my account actually. Just that way you guys can see like a developed GitHub account and what it's all about. Okay, cool. Let's see. I'm going to share my screen. Share my window. Here we go. Okay, here we go. So once you make an account, you'll see yourself here. This is the homepage of GitHub. And I mean, with your sign up, you can either sign up, with just your email or such, or you can use like your Google account from what I remember. You of course have to set your username, email address, password, all of that as we've seen. And GitHub actually has a few different plans. There's a free plan and there's a paid plan. The free plan is definitely a good place to start, just to kind of get yourself set up with just seeing what the site is all about. But the paid plan has some additional features. I just recommend like searching that up and kind of reading on it, see if it's right for you. So with all of that, so I'm just looking through my notes here. I guess, after you make a profile, of course, you want to verify your email, but you also want to, oh, perfect. Let's see. We have a create open source repo for beginners. Perfect. Thank you so much for that. That'll be nice, because especially again for this Global Hack Week, we are all about open source. So with that, it's usually a pretty good thing to like set up your profile and add a bio for yourself, add a profile picture if you prefer, so on and so forth. You can also include your website, location. Actually, let me see your profile. So you can see I have like my repositories here, which we'll get into. Remember, your repositories are basically like your different coding projects that people can they can download the code from your repositories. They can fork your repositories so they can make their own copies of them, so on and so forth. So you can see I have like I can set a profile picture. I have my bio that I added. It's pretty straightforward stuff. Nothing too fancy as of right now, but it's deceptively, again, you can deceptively do a lot through GitHub as a whole. So once you have your account set up and you go to your account here and, my profile, change your profile picture if you'd like, add your bio and any other relevant information about yourself. It's a good idea to just kind of see what GitHub is all about. So let's see if we can explore here. So there's this Explore tab, definitely a good place to start. You can essentially just check out popular repositories and see trending projects. So in fact, here's trending repositories. So you can see what other people are up to. You can kind of take a gander at Pokemon Red experiments. Let's see. Playing Pokemon Red with reinforcement learning. That sounds interesting. And 2, good documentation. Look at that. Oh, look at this cool GIF. YouTube video and everything too. So this is very, very good documentation, or at least, well, I don't want to say that just yet, but it's certainly flashy. It certainly catches the eye, I should say. Telling you what to do, talking about how the model is trained, so on and so forth. So the Explore tab is definitely a good place to start, just to kind of see different projects that people are working on, getting a sense of what's out there, and just kind of immersing yourself in ideally like proper GitHub practices and just seeing what's possible in terms of like what you can put out there. So the nice thing too is that you can also search for repositories that are related to your interests. So if I want to search more Pokemon stuff, Pokemon Go map, Pokemon Go bots, Pokemon Showdown. Ooh, I used to play a lot of Pokemon Showdown in school. Over 25,000 commits. That is awesome. So yeah, Pokemon Showdown is a website where you can simulate Pokemon battling. So you can basically play Pokemon with other people. This is sweet. So anyways, you can also follow users and repositories that interest you. So say I have an interest in this Pokemon Showdown, or this Pokemon Emerald here. The star will put it higher up on my list so I can, let me see. Oh, there's different lists that you can do. Okay, cool. So the star, and I can track the project. I can, kind of keep tabs on it, see what's going on with it. So that's just kind of a good way to jump into seeing what GitHub is all about with different repositories and such. 2, you can, ultimately you can download this code of all these projects that you see, and you can load it up in your code editor and just kind of peek around to make your own changes, so on and so forth. That's just like the very, very beginning of what you can do in terms of making your own contributions and, delving into things yourself. What we want to get into is how to make our own repositories, like how we want to make our own projects like these, how we want to contribute to pre-existing repositories or, to our own repositories, and how to collaborate with others as well. So now that we have a GitHub account and we've kind of see a little bit of what's possible with GitHub, we definitely want to do, as I said, we want to see how to use GitHub for version control, open source collaboration, and just software development as a whole. So let's see. We can go back to the front. Well, I guess there's a few other things too to kind of delve into. So discussions, users. So yeah, you can also follow users. You can make friends on GitHub if you're looking for someone to chat to, or if you find interesting projects that people are working on and you just want to keep tabs on those. So anywho, a lot to talk about, that's for sure. But let's see. I think we've touched upon enough with that. Let's get down to the nitty-gritty of creating a repository. Ooh, is that working? Okay, cool. Let's see. So if you want to create a place to host your own code, as in if you want to create a repository for a coding project that you're working on, you most certainly will want to create a repository. So creating a new GitHub repository is one of the first steps in managing your code and collaborating with others on the platform. We are going to walk through it a little bit, just kind of showing you what to do in order to make this happen, and also talk about some best practices like naming conventions and so on. So once you're in GitHub, you're going to want to click on New. And this is going to be a new repository. So as it says, a repository contains all project files, including the revision history. So let's just go on to make something. So if I want to name, what do I want to call it? Let's say MLH open source to GitHub. Give that a shot. So a repository made as a demonstration for Global Hack Week. GitHub. Okay, so as we talked about before, repositories can be public or they can be private. Repositories can be shared with just a URL. And if you want if you want the public to be able to see it, well, then just share that URL with people. If you want it to be private, then the person would have to have permission to view the code that's linked to that URL. So we're going to make this public. And we are definitely going to initialize the repository with a README file. README files we're going to talk a bit about, but certainly definitely important in terms of, again, just giving context to your project for others that are going to be jumping into it. What we saw a little bit earlier, like with those Pokemon GIFs and explanations of like what the project is, how to run it, things to know about the code when you're developing, that is where a README project, or that's where a README file shines. So add git ignore. We'll talk a little bit more about that once we get into git and the git command line. And choosing a license. So license, as it says, tells others what they can and can't do with your code. It's usually best practice to choose a license. Again, we'll kind of talk about that a little bit later. We won't even worry about it for now. Here, so we're going to create our repository. And there we go. Boom, boom, boom. Now we have a GitHub repository for our project. So again, this is just like the repositories that we saw earlier. So let me pull up one of those guys. So let's see what we have. Again, let's go to the Explorer. I think that's a little bit more interesting than anything I might have worked on. So we can go to trending. Ooh, even these are the same from before. But yeah, so just like how we created a repository here, this is in and of itself also a repository, just like what we had. But obviously this is a lot more fleshed out with multiple folders and files, and the README has a lot more to it, giving context to the entire project and how to install it and how whatever sort of context that you want to give for your project, which is most definitely project specific. Well, now we created a repository, so that is certainly a achievement in and of itself. So I guess just some things to know on best practice, or just like how to configure your repository overall. In terms of repository naming, you definitely want to choose a descriptive and concise name for your repository. So ultimately use lowercase letters and hyphens for the name. And the repository name should naturally reflect the project of code you're hosting. So you can see here that abides by those criteria, those principles there. So the description of the project, as we made out before here, repository made as demonstration. Ultimately, as with any description, it's just going to help other users understand the purpose of your repository. The description can be short but informative, and I think this one here definitely gives the full context. We already talked about visibility with public or private, and the README. So now that we have our repository created, let's talk about let's see if there's any other. I made some notes on different conventions and different conventions on what to follow. But I mean, I think it's pretty straightforward now that I'm looking back at it. Better to be over-prepared than unprepared. Okay, so now that we have created our GitHub repository, in fact, let me switch over to this guy. So we made our account, and we've also made kind of went through GitHub and some of its features, how to utilize it. We created our repository. Now we can talk about managing and adding files. So we want to definitely get to our repository, add files, manage them. Pretty straightforward, right? Pretty much in the name of the overall theme. But the importance of README files we'll also delve a little bit more into. So let's jump back into GitHub. Let me just keep on the chat here. Okay. Yes, thank you again for this resource. Super, super killer. We appreciate it. We love it. Awesome, awesome. Okay, so now that we have our repository created, we ultimately want to host a coding project on it, right? So we want to start adding some additional files. So what you can ultimately do is, if you couldn't guess it, click this add file button, and you can either create a new file or you can upload files from, like your machine and such. So let's try to create a file in GitHub. So again, you can code in GitHub if you want to. This is not what I normally see from people, just because a proper coding, just a proper coding environment will give you a lot of additional features and such. But it's all possible here. I've made some READMEs purely in GitHub at times. So let's maybe make a simple HTML file, the most basic one. Like, here we go. So I have this file added, commit changes. So now I'm going to take a snapshot of the project after I make this change here. So it's asking me, and by snapshot, I mean I'm going to make that commit to the project where I'm going to, just create another snapshot and give some, with my changed file or files, depending on how many you have. And with that, I can give additional context as to what exactly is going on. So my commit message here is, again, the only context that I really need is just create index.html. And I can add additional information, of course. And you can see we have choices of branches here. We'll definitely talk about branches in a bit more detail. But remember that branches are like that, kind of create a copy of the project, and you kind of work on it off to the side where you try to implement new features or maybe bug fixes, or ultimately you're aiming to edit the original project without like destructively affecting the original project, as in like without affecting it in a way that you can't reverse. It's just a really safe way of doing that. So we can do files this way. And you can see here, I have my index.html file here now. And if we go to, I'm surprised there's not a history. Let's see. Okay, here's my commit history. So after you make, a bunch of commits, like we can see here in this Pokemon Red one, there's 164 commits. So again, that snapshot is taken after all of these different things that are done to the code. So we can look at their commit history. We can see all the different commits that they've made. And we can see that, this person has given, they have given they've named their commit, some additional info and such. And you can see like the change code and such, which is super, super helpful. Again, this gives context and understanding as to what has changed since the last commit, and even at times like why changes have been made, if you want to give additional info, which is most certainly helpful. So here we only have 2 commits. We had the initial creation of the repository, and now we had the commit where we had, again, took that snapshot where we created this file and added it to the repository. So you can create files in GitHub with the create new file, or you can also upload files, which again I think that's a little bit more standard. You can add multiple files at once, and you can, again, we saw how to look at our commit changes. So you can click on any file to view its content or edit it directly in the GitHub interface. So if you want to look at the index.html, click on it. We can see here's that code that I typed in for it. And we can even jump in and start editing it if we wanted to. Let's say I put in another one. Let's say I want to change the code. I'm going to make an additional change to it. This is an additional change to this file. let's say this is an addition to the file. So I'm going to make another commit where we can just say that I updated the index.html. And for your commit messages here, I forget what we call it, but there's like a certain grammatical case that you want to use. Like you don't want to use past tense or anything. You kind of want to give it, I think it's called the declarative case. I'll have to look it up again off the top of my head. But anyways, you kind of want to do it like you're giving a command to GitHub. Like, do this, update index.html. Just some common practice stuff. It's considered proper practice to do that. So I'm going to commit my change. And so if I go to my Git history or my commit history, you can see now I have 3 commits because I updated that index.html. And I can see how it changed from the last commit, right, with this new line of code that it highlights. So again, pretty basic demonstration, but powerful stuff. Okay, there we go, imperative case. Thank you. Gotta study up on my English grammatical terms at some point. Okay, so we have that. And so we've seen how we can add files. We've seen how we can change files. We can also delete files if we wish to. So we might have to click inside of it. So we'll delete this index.html and go up here, go to, look, we can download, we can jump to a particular line. All the way down, we can delete the file in red. So look at it, this file was deleted. So now we go back. Oh wait, do I have to, probably have to commit that, don't I? No? Hold on. That's weird. Delete file. Yes, there we go. Okay, commit changes. There we go. So again, any of these little changes, it really depends on you, how much work you want to do before you make a commit. Obviously, every little thing that I'm doing now, I'm going to make a commit just as a demonstration because we're not really doing too much of anything as of right now, just to kind of showcase these functionalities. But there we go, delete index.html. And now we can see if we go here, it's no longer there, as you would expect from a deleted file, and you can see the additional commit that I made with that. And I can look at these past commits and I can see here I'm looking at an older commit, right? You can see this is like the particular commit that I'm looking at here. Does that zoom in, show up on here? Oh, nice. Okay, cool. There we go. Oops. Something like change button color or fix nav bar. Yes, exactly. That is the sort of stuff that you would see on for a Git commit. And so too, a good idea would be to like look up a web dev project, maybe even for just like a simple website or the like, and see how exactly they've structured their Git commits. What they deemed. Just kind of getting into their heads and sort of just getting some perspective on like what do they deem worthy as being enough work to get a Git commit. What have they how exactly and what sort of detail do they go into for each of their commits? Because there's just we kind of saw that, right? There was just there's the title of the commit, like these, update index.html, create index.html. In fact, let's get up to the most recent one. So again, we're looking at a past commit. That's why this index.html is still here, because again, there's those snapshots that you can go and explore. Here, so with a particular commit, well, I didn't give a description for it, so it's probably not going to show up at first. But again, you can give additional information with the description of the commit as well. So with that, so we've seen how to add, change, and delete files. We also need to look at how to, well, I guess we can talk a bit more about the README now. So the README file is an essential component of your repository. In fact, let's jump back to this guy real quick. Oh, weird. Thought I had one for you. Oh yeah, importance of README files. Yeah, the slide kind of cracks me up in hindsight. Importance of README files. So README files, well, it'd be more interesting to see again something like this. README file like this. Oh yeah. So README file is an essential component of your repository. It serves several important purposes. First, it serves as project documentation, including a brief description of the project's purpose, its features, how to use it, and any specific requirements. So like we see here, it does exactly that. It talks about the, well, yeah, here we go. Just there it is. There's the purpose of it. Its features and how to use it. So as we see here, how to use it, how to use it. The features, I'm guessing will be in the YouTube video, but we're not going to jump on that for now. And any specific requirements. So, you know, how to run it and so on and so forth. So README is important for the project documentation, just giving context and understanding to your project. It's also important for onboarding. So for open source projects, a well-structured README helps new contributors understand how to get started with a project, set up the development environment, and contribute effectively. Again, just like here, it accomplishes it very well. Proper README also gives user guidance. If your project is meant to be used by others, a README guides users on how to install, configure, and use the software, as we see here. It also gives project information. So README files often include badges, licensing information, contact details, and links to project documentation. This additional information makes it easier for users and contributors to understand the project's context and status. So it's not really in the nature of this project to include things like badges or contact info, so on and so forth. But you'll definitely see that with others. I wonder if we can, let's see. I think this free certifications one will probably have more of that. Ooh, okay, a lot of different certifications. That's pretty cool. Oh, I guess it's just, you'll see that too. It's just a database of different like resources to be used for anything. Omnivore. I want to see if there's something with badges. Here we go. So like, again, here's some social links and such. Contact details, might have licensing information as well. Very, very nice README. There we go, license, okay. So it just points to the license. Easy enough. So as we said, project information. A good README also shows professionalism. A well-written README reflects professionalism. It shows that you take your project seriously. It can attract more contributors and users. So that's a big thing too. You know, how your project is perceived is also as important as, you know, what it actually does. So as I was saying before, like if you have your eyes on the MLH prep program or the MLH fellowship, they say a big aspect of that is for the project that you submit for your application is having a well-documented README. So definitely do not underestimate that. And two, I've read lots of stories of people where they were applying for jobs, or maybe it was the recruiters talking. They said that, you know, someone that applied, their code wasn't the best, honestly, but their README and their documentation was so top notch that we went with them because of that. Because they could, you know, over time they can just like learn how to code better and such. But if they're putting the detail in right now to be able to effectively communicate their code and their ideas and such to the team as a whole, well, then that's, you know, that's invaluable right out of the gate. So definitely do not underestimate that. How does staging come into play here? That is a good question. I think we'll be more readily able to talk about that once we get to the Git command line. So good question, but we will delve into that once we get to there. So ultimately, well, I guess just a little, let me jump into there a little bit. Let's see. So what am I on my Git command line? So, okay, forget basic commands. I mean, if you want to just the really, really short answer before we get to it ourselves, is that certainly comes into play once you start with the commands like git, from the git commands of like git add to git commit. That's where staging starts to take place when you're dealing with git add and git commit. But we'll go into that in detail ourselves a little bit later on. Definitely a good question though. Okay, so we were doing README files, yes. Okay, so again, a good README showcases professionalism. And two, it can even get you the job from stories that I've certainly heard. README files also help with SEO and discoverability. So README files are indexed by search engines, making your project more discoverable online. So again, you definitely want to make sure that you fill it out, put relevant information in. And as well, README files, which we've kind of, arrived at, is that README files are a primary way to communicate with potential collaborators or users. They introduce your project, its goals, and how it can benefit others. Some READMEs even include version history. So with them including version history, as well as change logs, it ultimately helps users understand the project's development timeline. So overall, creating and maintaining an informative README is a best practice for GitHub repositories. It not only benefits you as a project owner, but also helps your users, contributors, and anyone else interested in your project. It's overall a valuable tool for effective communication and management. So with that, let's talk a little bit more about collaborative work on GitHub. So let's add a U back on. So collaborative work on GitHub. GitHub's collaboration features are designed to support the collaborative development of code and the coordination of tasks among team members. So these features include adding collaborators. You can invite other GitHub users to collaborate on your repository by giving them access. Collaborators can make contributions, open issues, and create pull requests. Collaborators are essential for group projects, open source development, and team collaboration. So in fact, I'll try to explore that on this little repository here that I have open up. So if I want to invite collaborators, let's see, collaborators. So we can see who has access. Repository is public and visible to anyone. But if I want people to be able to make changes to it, then I can go, again, you saw how I went to the repository, I went to settings, I went to collaborators on the left-hand side here, and then you can add people, and you can add them by either username, full name, email. And once I add these people or this person, they can then come in and edit the repository themselves, as if they owned it. So they can add files, make changes to files, and some of the other features that we'll come to see as well, like pull requests, issues, so on and so forth. So you can add collaborators. There's also branching and merging. So GitHub allows developers to create branches for different features or bug fixes. Once work on a branch is complete, it can be merged into the main code base, often through pull requests. This feature enables parallel development without conflicts. So we definitely talked a bit on this earlier. We can look at, well, let's see. Do I want to look at, let me just look through my notes again. We'll go over branching and merging and such in more detail in a little bit. So with branching and merging, there's also pull requests. So pull requests are used to propose changes to a repository. They provide a structured way for contributors to submit code for review and integration. Pull requests are essential for code review, discussion, and collaboration before changes are merged into the main branch. And issues, GitHub's issue tracking system helps users report and discuss problems, propose new features, and manage project tasks. Issues can be assigned to specific collaborators, and they provide a central location for project-related discussions. So, I mean, this will be a pretty simple one to show because like we can just click like boot to issues. So you can go in and make issues. So issues are used to track to-dos, bugs, feature requests, and more. So we can go on to make our own issue. So let's say like we, you know, index.html needs.ccs file. The page is currently has. I deleted the page actually, but let's pretend that I didn't. Let's pretend we're gonna add it back, but we still need styling. I don't know, however you want your imagination to, however you want to rationalize this. Sounds good with me. We need to implement it, something along those, or you know, if there's bugs or something that people have come across, they can give information on here. Submit new issue, and you can see that within the overall repository now, you can see it has a place for the issue now. And you can see, okay, here's the issue. Here's the issue with it, and then usually what people will do is that they'll, you know, make a copy of the repository, download the code from there, make that change in their copy of the code, put it back up to GitHub, and then try to merge their fix with the original code base. And if that fix gets approved, if it goes through all the gates that people have set up, then they can ultimately implement their change into the final, you know, into the original final code base. So that's how this workflow goes. So, and then too, this opens a discussion. So people can jump to the comments. They can ask for more context, so they can, you know, say X, Y, Z. I'll work on this. You know, because if there's a team of people developing and contributing to the project, you can just kind of see the social aspect here, the collaborative aspect here of how this all comes together. Again, this is a big part of what makes GitHub shine. So with that, that's issues. So as we said, issues can be assigned to specific collaborators. So if you want a particular person to work on a particular issue, that's definitely possible. And they provide a central location for project-related discussions, as you saw, like with the comment section and so on. There are also project boards. So again, on the theme of collaborative work on GitHub, project boards, GitHub's project boards enable the organization and tracking of work using a Kanban style approach, which is like a certain method of organizing tasks and tracking the progress on them. You can create columns to represent stages of work and manage issues and pull requests accordingly. In fact, let me see. I'm really curious about that actually. Let's see, GitHub project board. Sorry, I'm just reading a little bit more documentation on it. We'll not have to delve into it. We actually have quite a bit to cover still, and we have less than an hour left. Crazy how time flies when you're having fun learning about GitHub. Okay, so anyways, here. So my issue, when we talk about project boards. So we talked about how to add collaborators to a GitHub repository. And two, we've talked about how you can access permissions for them. So some collaborators, you can set it to where they can only read, so they can only like view and comment on issues, pull requests and discussions. You can have them write so they can make changes to the repository, create issues, and push the branches. And then you also have like admin collaborators where they can manage, they can, you know, change everything about it, and they can also manage collaborators, so they can add and remove them. They can access more of the more fundamental repository settings, so on and so forth. So, okay, so that is all about collaborating with the repository. Now, as I talked about, there's a bit more to that process where people are going to, again, make a copy of the repository, which they can then copy the code from and work on the code themselves, make some changes, like on their local machine, on their computer. And then you push that code back upwards into the copied repository. so that your code then goes from your local machine back onto GitHub, and then you can take that copied, altered code and ultimately at least try to implement it into the original repository so that it's part of the original project. So far as whoever's running that original repository grants you access or grants you permission to do that, which is where pull requests and everything comes in. So again, everything is starting to come together here. So with that, let's talk about this. Let's talk about forking and pulling requests. So forking and pull requests are essential collaborative features in GitHub that facilitate the open source development process. They allow users to contribute to existing repositories, suggest changes, and maintain a structured review and merge workflow. Let's explore these concepts in a little bit more detail. So forking is the process of creating a personal copy of an existing repository. When you fork a repository, you duplicate it in your GitHub account, and you gain full control over the copy, allowing you to make changes, add code, and even make it a part of your own project. So let's go ahead and let's try to fork a project here. So I'm on here. This is my own project. I don't really see the point in forking it. So again, let's go see what other projects there are. So I'm going to go to explore. Let's look at trending. Let's do Pokemon Red experience, since we've been using this one anyways. So again, if I want to make copies to the code, or I want the ability to edit it, so on and so forth, I'm going to fork it. So I have this button up here, fork your own copy of this Pokemon Red experiments. And you can see I'm creating a new fork. As we said, a fork is a copy of a repository. Forking a repository allows you to freely experiment with changes without affecting the original project. So it's all about being non-destructive. So now this is the repository name that I'm going to go with for my copied repository. The description is the same. Stuff with branches, we'll talk about that. I'm going to create my fork. And now on my profile, you can see I have this Pokemon Red experiments. So there we go. So this is my copy of the initial repository, right? I forked it. I made my own copy of it. So now I have access to all this code, and I can download it to I can edit it in GitHub, as we've seen that we can do before, or I can also download the code to my local machine and edit it in something like VS Code or any other sort of code editor. It's really up to me what I want to do. I have full control over it now with my now forked branch. So with that, what do I want to say? Well, I mean, that's just that's the basic demonstration of forking, and we can talk a little bit more just on forking as a whole and sort of its overall purpose. So, so one of the purposes of forking is contributing to open source. So forking is commonly used in open source projects. It enables external contributors to suggest changes without needing write access to the original repository. Another purpose of it is for collaboration. So team members or collaborators can fork a repository to work on features, bug fixes, or experiments independently without affecting the original code base. And third is for project adaptation. Forking can also be used to create a customized version of an existing project to meet specific requirements or preferences. This is actually a pretty cool utilization of it. So say you find a repository, you find a project on GitHub that you like, but you want to use it as a basis for something else that you want to do, or you want to just kind of take it in a new turn. You want to build off of it to make something new or to make a heavily modified version. You can just fork it, and you can start with that. And you want to make your own thing with it, or make heavily whatever you want to do with it. Very, very helpful. So that's forking. Other aspect to know about is pull requests. So a pull request is a proposal to merge changes from one repository, known as the source branch, into another repository called the target branch. So pull requests are used to facilitate code review and discussion before changes are merged into the main branch. So as we said, so say say I have, so I went to that Pokemon Red experiments project. I created a fork And I then go on to edit the code, and I have edited the code, whether it's on GitHub or on my local machine, and I ultimately update my fork of the repository so that it has new altered code. And what I want to do is then merge the changes that I made in my copied repository, the one that I forked over, into the original repository. So I can merge the changes from my copied repository into the original repository via a pull request. So we can see that it already has some pull requests here. Going back to the original project, we can see that there's 6 pull requests currently. So essentially these people, again, they forked this project themselves. They made the necessary changes that they felt were apt to be made. And from there, they initiated a pull request so that those changes can be implemented back to the original project, because those changes were meant to, fix something or implement an additional thing into that original project in the first place. So I'll go back to mine. So anyways, let's talk about now how to initiate a pull request. So as we know, we want to fork it first, which is already done. So we can see that I'm here in the forked repository. So this creates a copy of the repository in my GitHub account. And then you usually want to clone the forked repository, where as in you want to download all the files onto your local machine. Because again, you're usually not going to do all your heavy coding work in GitHub itself. Usually you're going to want to copy those files onto your computer or your local machine so you can work on them yourself, which will go on in just a minute. But yeah, this is kind of where we get to the Git command line. How many of you worked with the Git command line before? Like, how many of you have gone on to interface with, or how many of you gone on to interconnect Git on your local machine with GitHub and have done things like polling a repository, making some changes to it, and then pushing it to the repository? I'm just curious. Okay, nice. So you have some experience with that. I think we'll go over that in detail once I talk a little bit more about the Git command line in general. But ultimately what you'd do is that you'd copy this code onto your computer, make some changes, push it back up into, so you have the changes on your computer, but you have to get those changes onto GitHub. So then you'd tell your computer, hey, push this to GitHub, so the changes are now reflected on GitHub, and then you can do your pull request. So for example, we can look at some of these pull requests here. So this one looks pretty easy. Someone just corrected some grammatical errors in their README. So we can see this is the source repository, and so this is the original one that they're trying to merge their changes into, and this is the why am I drawing a blank? I think we called it the. Oh no, I'm sorry. This would be the source. This would be the target. So yeah, we're ultimately just trying to put the changes from one into the other. So from there, so no clutter with Git command line. Yeah, it's honestly a little bit of a skill in and of itself. It's not too hard to pick up. I definitely want to cover some of the basics with it, but as long as you understand the overall logic to it for now, that should be fine. You fork the repository, so that you don't end up altering the original repository. You download that code onto your computer, you work on that code, you take that altered code, put it back into GitHub, and then you can merge from your altered repository that you forked, your forked copy, with its changes to the code into the original. So we'll kind of see that here. So again, you can see this is the original repository that we want to change ultimately, or at least try to. This is a fork that someone made so they could work on that change. So we can open this up. We're going to look at the forked repository that had the change implemented on it. So you can see it's right. It's just like the other. We're not going to see any major changes because all they did was make some radical changes in the README. So we can see that up here it says, what is it? Well, it's talking about like the branch stuff, but we'll kind of get to that in time. Anywho, so there's one commit that they made, right? They made just that one change. So remember how we looked at, we made a number of commits to the one very simple repo that I made before. This person just made that one commit because they only changed one file and they only really did one thing. They just corrected the grammar. So it makes perfect sense to only have one commit. So we can see here, right? If we look at that commit, just corrected grammatical changes. And now we can see in the code how these were changed, right? The red is the old, I have a really heavy blue light filter on my screen. So I don't know if this is blue or green or what, but there's this contrasting color from the red, which shows these changes. So with that, there's the changes to the code, and then too, you can see there's a conversation about it. People are talking about, the context to it. If there's anything to discuss with it. I mean, this is a pretty straightforward issue, but if there's something a little bit more technical, usually it can require a little bit more discussion. Okay, so they're having a civilized conversation. Very, very nice. But anyways, so with that, you can see this is this pull request. They're trying to get it implemented into the main project. Kind of looks like, I don't know if it's going to get added. So I think the person got a little bit happy with making particular changes. Bless me. Okay. Anyways, so then ultimately, if it's a change that the original repo owner is going to want to implement, then they'll approve the pull request. And if your pull request gets approved, then it gets just, your change is reflected in the actual files on the original repo. If it's rejected, well, then I guess it just doesn't see the light of day in the original one. But yeah, so that's the basis of like forking and doing pull requests, right? So forking, you make a copy so that you can make your intended changes, and then you can use the pull request to communicate with the creator of the original repository, so that you can so they can like vet your proposed changes, and they can either approve them to get integrated, or they can deny them. So this is ultimately a little bit more about the review and merge process, as we saw here. The project maintainers and collaborators can review your changes and provide feedback through comments on the code, as we see here. Once the changes are reviewed and approved, a project manager can merge the pull request into the main repository's branch. Merging incorporates the proposed changes into the original code base, and the pull request is marked as closed. The changes you contribute are now a part of the original repository, and your contribution is credited in the commit history. So as we see, let's go to the commit history. So we have with these 164 commits, and we see these different like accounts that aren't the original owner of the repository that were ultimately implemented, and so again they're reflected in the commit history as a result. So overall, forking and pull requests are integral to the open source and collaborative development model on GitHub. They promote transparency, code quality, and teamwork by providing a structured and controlled way to contribute to projects while maintaining the original repository's integrity. So that is, I'd say, like the most fundamental basics to know about when it comes to just using GitHub and like understanding how to alter and contribute to projects. I know we were talking a little bit before about using GitHub for open source. I hope that gives additional context into that point of discussion. Does the pull request stay in the repository? So as we saw, it's marked as closed. So the status of it does change. Let's see, the Git website offers a free book to learn Git that could be useful for you. Yes, definitely. So this is a intro to GitHub. So it's certainly been very GitHub focused that we've been talking about. But I mean, if you use GitHub, you most definitely 99% of the time are going to want to use Git as well. The two just go hand in hand. It's almost like you can't have one without the other. I think most people would say that like in a practical way. You definitely want to use Git to interface with GitHub, and even vice versa. So thank you. Yeah, thank you for sharing the Git documentation. I think that'd be a very, very big help for people. So more on the theme of GitHub. Oops. Oh, hold on a second. My notes are freaking out. I like having notes. That way we can stay structured and on topic. So there's also GitHub desktop applications. I actually don't really know how popular these are. Everyone that I've talked to, at least, just always uses the GitHub website. In fact, I did not install the GitHub desktop application. If you just Google it, there's going to be other resources that show you just what it's all about. But I guess it's kind of good to know that it exists in case there's those of you out there who prefer that. Okay, let's see. How do you clone an existing project from a local machine to a GitHub repository? So yes, think first just got it exactly right. In that case, you push it with the git push command. So, and even before then, you have to, so say you make a Git project on your computer, right? You're making your code, blah, 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 blah. You're ready to post. So let's say you've just started out a project on your computer that you just started the code. And this is the very first thing you've done with it at all in any dimension, in any way. So you start coding your project, you make some changes, whatnot. You made it a Git project, you've been doing changes and such. To host it on GitHub, to take your Git project and host all the files from it onto GitHub, you would have to, as Thingiverse said here, you'd have to do the git push commands. But before then, you'd also have to sync up your Git project with your specific GitHub repo, so that when you tell Git, hey, I want to push this project onto GitHub, Git knows what exact repo you're looking to target. So again, that's we can definitely are going to talk about that in a little bit more detail, so long as we have the time in terms of like how to technically do that. But that's the overall idea. You know, if you definitely read about Git push, if you Google that and read about it, that will definitely get you all the right information on what you need for that. But with that, again, kind of I don't really ever hear people talk about GitHub desktop, but maybe it's just not a thing in my particular circles. But it is a thing. GitHub Desktop is a graphical user interface application provided by GitHub for simplifying the use of Git and GitHub for version control and collaborative development. It is designed to make it easier for developers, both beginners and experienced, to interact with their repositories and collaborate on projects. So just a bit to know about GitHub Desktop. It ultimately sports a user-friendly interface, an intuitive and user-friendly interface, making it accessible to developers who are not familiar with the command line. There's also repository management. You can create, clone, and manage Git repositories directly from the application. It provides a clear visual representation of your repositories, branch history, and changes. There's visual diffs, easily visualize changes and differences in your code. So like we saw, so in terms of diffs, I mean, that's just, I feel like it's better to kind of see it again so that you know what exactly that's referring to. So like we saw here with, like these are your diffs, like these are the coding changes. How there's that color contrast showing how things are different. Showing the changes in the code and such. So yes. Visual diffs easily visualize changes and differences in your code, including side-by-side comparisons of file changes and easy access to code reviews. Branch management. Create, switch, merge, and delete branches from within the application. We haven't talked about branches in detail just yet, but we definitely have a portion on that. But with branch management, it allows you to create, switch, merge, and delete branches from within the application. This makes it simple to work on multiple features or bug fixes concurrently. It's also commit and push, very, very big. Quickly commit changes and push them to the remote repository. So as we were just talking about right now, right, if you make changes on your local machine to the files and you want those changes to be reflected on GitHub, on the GitHub repository that is analogous to your code base on your local machine, then GitHub Desktop also has that built in with its commit and push. So commit, again, is like making the snapshots, and then push is taking the files on your local computer and updating the GitHub repository to reflect them. So the application, the desktop or the GitHub Desktop application guides you through the commit process, making it easier to add meaningful commit messages. Also helps with pull requests, create and review pull requests directly from the application. You can start a pull request for your branch, see a list of pull requests in the repository, and provide feedback on code changes. You also have access to GitHub features. So GitHub Desktop integrates with your GitHub accounts, so you can easily switch between your repositories, see your notifications, and access GitHub's features without leaving the application. There's also cross-platform. So GitHub Desktop is available for Windows and Mac OS, ensuring that developers on both platforms can enjoy a consistent experience. So in that same vein, there's other GitHub-related tools that are helpful to know about. Oh, look, we got, I think, verse 2. Yeah, as a strict command line interface user, the GitHub Desktop is infinitely better for viewing diffs. Yes, I can certainly imagine. Command line interface is a bit, how would you want to say? Definitely not meant for visualization. That is not the goal with it exactly. So yeah, I mean, each method has its benefits and sort of weaknesses. I'm also a strict command line user, and I definitely agree with you that I could imagine something like desktop, or even just like I usually use the GitHub website at times, like with my repository and the code uploaded there for viewing diffs and such. So different tools for different tasks. Definitely true. For command line user interface power users, here's a tip: check out FZF. I'll have to make a note of that to look into it myself. Thank you for that. Phasic. Okay, so there are other tools and services that complement the GitHub ecosystem. So one is the command line interface. So the GitHub command line interface is a command line tool that enables you to interact with GitHub repositories, issues, and pull requests from your terminal. It's a powerful tool for automating GitHub-related tasks. There's also GitHub Code Spaces. Code Spaces provide an online development environment directly within your browser. It's particularly useful for developing, testing, and contributing to open source projects without the need to set up a local development environment. GitHub Actions, which is an automation service that allows you to automate your software development workflows. You can create custom workflows to build, test, and deploy your projects on GitHub. GitHub Pages is a feature that allows you to host websites and documentation directly from your GitHub repository. It's a simple way to share your project or documentation with the world. GitHub Pages is super, super helpful, especially for, I use it a lot for web dev stuff. So if you have a web project, if you have a website project that you have as a repository, it's super, super easy to, instead of like buying a domain name for it and dealing with all that, you can just host the page directly from your GitHub repository. So like your GitHub repository will you can just make your own, GitHub will provide a URL for you and host it directly from the files that you have in your repository. So it's super, super streamlined. It can be super, super useful. If you have a project that's not like so serious that you want to buy a domain for it, but that you do want to see how it interacts with like live on the web. So very, very helpful for us web developers out there. Last but not least, there's also GitHub API. GitHub offers a REST API and GraphQL API, allowing you to programmatically access and interact with GitHub's features and data. This is particularly useful for creating custom integrations and automations. So all the fun stuff that you may know about using APIs that is also available for GitHub. So overall, GitHub Desktop, along with these other tools and services, enhances the GitHub ecosystem, making it a comprehensive platform for version control, collaborative development, and automation. Depending on your specific needs, you can choose the tools that best suit your workflow and development environment. So that is GitHub Desktop, but now we're going to move into probably has a little bit more of representation, at least in this stream, is the Git command line. So Git is a distributed version control system that allows you to track changes in your code, collaborate with others, and manage your projects effectively. While there are graphical user interfaces for Git, as we saw GitHub Desktop, it's essential to understand the Git command line for a deeper understanding of how Git works and to have more control over your version control workflow. So some of the key points about using the Git command is you do have to install it. So they do have the official website that you can seek out and to be able to use that. There's also commands for repository initialization, the git commit commands. I don't want to delve in too heavily into Git in this presentation just because we don't really have too much time left. And there's a lot of great resources online. Like we had someone post the, here we go, we had ThinkVerse post the source for the GitHub, for the Git documentation, which certainly helps. But with that, these are your basic Git commands that you want to be aware of. Again, we're not going to spend too much on here because this is more about GitHub specifically rather than Git itself. But you know, some other things that are helpful to know. Git definitely helps you with creating branches of like you know, of a code base of a Git project. It helps with collaboration. There's GitHub integration, as we were talking about with Git pull, where you want to download the code from a repository onto your local machine, and then Git push when you want to take the code from your local machine, usually the code that you've altered, so that you can then push it up to the repository, so that the code on your local machine is then represented on GitHub. And you can also like undo changes and such. So again, Git is definitely, if you want to use GitHub, definitely look into Git. Very, very big, very, very important. So in terms of popular Git clients, while the Git command line is powerful and flexible, some users prefer using graphical Git clients for a more visual and user-friendly experience. So some of the popular Git clients are going to be GitHub Desktop, as we talked about a moment before. Again, it provides an easy-to-use graphical interface for Git and GitHub, making it suitable for developers to prefer a visual approach. There is SourceTree, which is a free Git client that supports both Git and Mercurial. It offers a visual representation of repositories, branches, and commits. Git Kraken is a cross-platform Git client with a rich feature set. It includes tools for code collaboration, issue tracking, and boards. Tortoise Git, I love these names, man. Tortoise Git is a Windows-specific Git client that integrates with the Windows shell. It allows you to perform Git operations through context menus. Git Cola, a lightweight and open source Git client with a simple and intuitive interface. It is available for Linux, Mac OS, and Windows. SmartGit is a Git client that supports Git and SVN. Offers a comprehensive set of features, making it suitable for advanced users. And then finally, we have Tower, which is a paid Git client available for Mac OS and Windows. Provides a feature-rich interface for managing Git repositories. So these Git clients can be an excellent choice if you prefer a GUI or a GUI-based approach to Git, or if you're just getting started with version control. They often offer visual representations of your repositories, a streamlined workflow, and integration with popular Git hosting services like GitHub and GitLab. Though, again, at the end of the day, at least most people that I've talked to, we prefer the command line interface for Git, where you're just kind of just staring at a black screen with letters on it. So, but nice to know your options. And these are definitely things for you guys to explore yourselves and see what you prefer. Okay, so best practices and tips. Let's delve into issues. So GitHub best practices and tips are crucial for effective collaboration, project management, and code quality. One essential aspect of project management on GitHub is managing issues. So we're going to discuss best practices for managing issues here. The importance of issue tracking and how to use labeling, assigning, and closing issues effectively. So for managing issues, a couple things to know. Use descriptive titles. So provide clear, concise, and descriptive titles for your issues. So again, just to clarify, right, we're looking at issues, right, on this issue tab here, where you can go and make your own issue. So because again, if you see a problem with the code base, your ability to help get it fixed is only as effective as your ability to communicate about the issue. If other people aren't aware of it and you're trying to tell them about it, you have to make sure that you can communicate about it as effectively as you can, so that it can be tackled and resolved as effectively as is possible. So with that, you definitely want to use descriptive titles. So provide clear, concise, and descriptive titles for your issues. A good title should convey the problem, feature, or task the issue addresses. For issue, there's also issue templates. Consider using issue templates to ensure consistency and structured information in your issues. GitHub allows you to create custom templates for bug reports, feature requests, and more. That is certainly a very, very big help, especially for larger projects and more, I guess you could say more decentralized or diverse set of people working on a project, right? If it's just like the same two people working on something, then it might not be as important to organize things and to have a structured template in place. But if you have, if anyone can come in and contribute stuff like an open source, then most definitely helps to have the structure to how things are done and how information is organized and conveyed. So detailed descriptions. Provide detailed information about the problem, task, or feature in the issue description. Include context, steps to reproduce, and expected outcomes for bug reports. For feature requests, explain the use case and benefits. So yeah, for any issues, right, if it's like a really weird issue that you have to do very particular things for it to pop up, then, well, it certainly helps to let people know about that, what they have to do so they can test it for themselves and see if it's reproducible in the way that's being described, or in whatever way. Again, context and communication is everything, especially when collaborating on something, and especially for something like open source, because collaboration is just such a big part of that. Tagging and labeling. Assign appropriate labels to your issues. Labels help categorize and prioritize issues, making it easier to filter and manage them. Common labels include bug, enhancement, help wanted, and good first issue. So yeah, like a bug, if there's just a issue with the code, right? If there's a problem with it that needs to get fixed, you can label it as a bug. I've definitely seen good first issue. That's for for good first issues, those are nice if you're looking to get started with contributing to a project. Like maybe you just never done open source stuff overall, and that would be a good one for just kind of getting your feet wet in that whole world. Or if you're new to a particular project, a new particular code base, and you just need a simple issue that will help you, that doesn't require too much intensity in terms of like what you've done in the code base already. Like you can kind of jump into it without much prior experience in that particular code base, and it'll help you get up to speed a little bit more, while also, fixing a legitimate issue that needs to be addressed. So there's also like communities of open source. There's like communities where people will aggregate different open source projects that have like good first issues for people to tackle that are relatively new to it. So I know we were talking about in the chat before how like people were asking about how do you contribute to open source, good first steps, so on and so forth. Seeking out one of those resources of where people put together a collection of first issues to tackle is definitely a good first step for that. You can assign issues. So assign issues to specific team members or collaborators who are responsible for working on them. Assignees can be individual contributors or teams. There are milestones, which help group related issues together. You can use milestones for version releases, sprints, or project phases. They provide a visual representation of project progress. Again, use of comments we want to give context. We want to also have communications, like if something is being worked on actively, and there's a roadblock in what you're trying to fix, or if there's been a big milestone that's been hit in the overall resolution of this issue, you want to be able to talk to people about it. So user comments will encourage discussions and collaboration on issues. Users can comment with feedback, suggestions, or solutions. Keep discussions constructive and focused. Yeah, I guess status updates is maybe a little bit more what I was talking about a second ago, but you can see how the two go hand in hand. Status updates, you can regularly update the status of issues, change the status labels from say an issue is in progress or it needs review. So if it's in progress, then someone's working on it. If it needs review, then it's at a state where a project manager or where a collaborator can look over that person's draft of the fix to be implemented. So, and then integration with pull requests. So when resolving issues, you can reference the related pull requests in the issue description. GitHub automatically links the two, which is beneficial for code review and verification. So yes, very powerful feature for when you are implementing your stuff, or at least attempting to via pull request. So just talking a little bit more on why issue tracking is so helpful for the development of a project as a whole. So working with issues and, as a whole for a GitHub project, it leads to structured workflow. So helps create an organized and structured workflow for tasks, bugs, and features. Issues are a central hub for managing project work. Let's see what else we have coming up. We have not much time left. So let's get through to the end of this. We'll kind of just breeze through some of these stuff. And, at the very least, you can be cognizant that these things exist. So we have branching strategies. So branching is a very crucial concept for effective version control and collaborative development. You have to read up on branching. It is so important. Sadly, we have little time to cover it in detail, but just know about it. Again, it also is very, very big when you're working with Git itself. So branching. Okay, so there's also best practices for managing branches, as we can see, naming conventions, like the scope of a branch, like how many changes do you want to implement in one, permissions, documentation, communication, so on and so forth. GitHub etiquette, just don't be a meanie and make sure to don't be a meanie and try and be constructive. Those are the two big ones, I would say. And let's talk a little bit about GitHub and real-world applications. So I think this is a pretty interesting, we're basically at the end of it now. And it's a pretty interesting point to end on, I would say. I always like seeing how things are, it's nice learning about these things just in and of themselves, but I also really, really like knowing how it's actually utilized in the real world, because what's the point in this stuff if it doesn't have any actual use? So GitHub and real-world applications, it is used for Linux kernel. One of the most prominent open source projects, the Linux kernel, is hosted on GitHub. Thousands of developers worldwide collaborate to maintain and improve this critical piece of software. We talked a bit about Microsoft. Microsoft has embraced open source development on GitHub, contributing to projects like VS Code and developing open source tools and frameworks. As we said before, GitHub was even acquired by Microsoft, highlighting its importance in the software industry. Those are more like the software development angle. For web development, there's Bootstrap. GitHub hosts the development of the Bootstrap framework, which is widely used for responsive web design and front-end development. That is definitely a fact. Bootstrap is very, very popular. Jekyll, GitHub Pages, powered by Jekyll, is a popular platform for hosting websites directly from GitHub repositories, as I was talking about before. It's widely used by bloggers, developers, and organizations for creating and hosting websites. Data science, if you guys would have heard of these, if you attended the one open source and data science event that I hosted the other day. But there's Jupyter Notebooks. Jupyter Notebooks are essential for data analysis and machine learning. They're often shared on GitHub for collaboration and reproducibility in the data science community, as well as scikit-learn, a machine learning library for Python. It is developed and maintained on GitHub, demonstrating its importance in the data science field. And for game development, Godot Engine, open source game development, actively developed on GitHub and used by game developers to create 2D and 3D games. Unity Technologies. Unity is primarily known for its proprietary game engine. It has embraced open source development and uses GitHub to share code and projects with the community. A couple more points on this. COVID-19, open source was a very, very big aspect of just basically sharing. There are a lot of repositories for like related to COVID-19 research, data sets, and epidemiological models, which certainly helped the campaign on that. And with Raspberry Pi and Arduinos, people will share like hardware design, software projects, and resources. Quite a few more. And there's these. I also wanted to share before we hop off. We have these learning resources, which we looked at a little bit earlier. So if you want to learn more about GitHub, you have these sources here. And if you want to, if you need any support or if you need to discuss things about GitHub, its use, anything that matter, we have all of these different communities and forums here. So we're basically at the end of the hour. If there's any questions or the like, please let me know. We only have about 2 minutes left, but you guys have been asking some pretty good questions throughout the presentation. So I think we've got the major stuff out of our system. But yes, if you have any questions or there's a previous slide you want me to go back to, just let me know. We'll just wait a couple minutes, see if there's any discussion on that point. And if not, then we can call it a night. Here we go. Yes, thank you so much. I appreciate you guys tuning in and, just joining me for this. I hope you get some good insight. I hope it, shed a light on GitHub's history, its features, its workflow, so on and so forth. Awesome. Glad to hear it. Very, very glad to hear it. So that's what we're all about at MLH. Helping the tech community thrive, learn, have good experiences. So, okay. Well, I think with that, no questions. Appreciate you all for coming and taking part in this. And I hope you guys enjoy the rest of your Global Hack Week. Yes, thank you. With that, have a good night, everyone.